Hello everyone, for this tutorial video I like to explain simple series circuits that involve an inductor and resistor. You should be well versed in how inductors alone work with AC as discussed in the last video, as well as how resistors work with AC as discussed in a previous video, in order to be prepared for and understand the reasoning used in this video. In particular, we start by noticing because it is a series circuit, we can assume the resistance in total is a simple summation of the individual resistances. And although this is true, we must also remember that while the resistor gives a simple resistance, the inductor does not. So it will be an addition of phasors rather than an addition of normal numbers, aka scalars. We know the phase of a resistor's resistance is 0 because the voltage and current are in phase. And we know the phase of an inductor's reactance is 90 because the voltage and current are exactly 90 degrees apart from each other. And we also know for the resistor, the resistance is given off the bat. And for the inductor, we have a formula for the resistance, which was the X sub L thing. So we can somewhat easily express this in rectangular form as 5 plus J0 for the resistor and 0 plus J reactance number for the inductor. And we conclude that the total resistance is exactly 5 plus J reactance number ohms. Or once we convert this back to polar form, or normal vector form, we get 6.262 ohms at a specific phase of 37.016 degrees. And the technical term for a total resistance, when it involves both a normal resistance and a reactance, is called an impedance, and is represented with a capital Z. And this should make sense like reactance, because we know to impede something means to block its progress. And that is exactly what an electrical resistance does. So we can also get a form of Ohm's law that works for complex AC circuits by stating voltage equals current times impedance, although it should be somewhat obvious that voltage and current would be complex vectors as well. It would not be simple numbers like in DC circuits. Now that I've explained how simple resistor-inductor series circuits work, I can explain how simple inductor-resistor parallel circuits work next, which uses about the same reasoning. The only difference is that we would use the equations for parallel circuits rather than series circuits. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.